Hello, my name is Teng Wang. Today I want to introduce to you the 3D and 2D real highway hump crossing automatic evaluation software we developed at the University of Kentucky. So you can find our contact information as listed here, and also if you want to know more about the software, you can also use this QR code to find me. So let's get started. So we first want to show you the 3D version of the software. And so this is our user interface. And first we need to open actually the crossing 3D point cloud. So this 3D point cloud of the crossing is obtained from the LiDAR scan. So this basically we convert the LiDAR data into the XYZ 3D axis, 3D data points cloud here, as you can see. Then for sure this is your 3D view. You can also have the profile view of the point cloud, and you can also have the plan view or the bird view. Then next, for each different vehicle, we did the test. We have this simplified vehicle model here, as you can see. So for each vehicle, we basically divided into 3 parts. So you have the front overhang, you have the rear base, you also have the rear overhang. And for each part, you have the dimension and you have the clearance. So basically, we have several different vehicles with longer wheelbase you can use to do the analysis, but also you can change to any vehicle dimensions, any other kind of vehicle. If you have the vehicle dimensions, you can use. Let me open the Excel file where we stored all the vehicle dimensions. Okay, so after you used the input the vehicles information, you click calculation. So now the program is running in the background to calculate all the different vehicles, to simulate when the vehicle drive over the surface or the potential contact point at the bottom of the vehicle and the pavement surface. So actually you can see each output for each vehicle drive on the same surface will start to be created on the desktop. Okay, so now all those 7 different vehicles were finished the calculation and the simulation and the calculation. Now we can show the result. So we pick the first one, the rear-loaded garbage truck. We can get the plot. So there's nothing on the showing on here except the highway surface as the plan view of the surface. So no dots there. That means for the rear-loaded garbage truck, there's no contact point here. But if we change to a car carrier trailer, plot. So for this one, they're starting to have some contact point, and the contact at each level, if it's like start to be contacted, they're showing in the light yellow color. But if there are small dangerous situations, start to show in the darker red or even to the black color. The top view here is for the cross surface, the bottom is for the vehicle bottom, to show which part of the vehicle at the vehicle bottom have the most dangerous area to be contacted at the surface. So for all the vehicle listed here, we can see which vehicle have the most dangerous situation for this particular crossing. And for sure, for this crossing, the car, carrier, trailer are the most dangerous, as the virtual surface of the bottom of the vehicle can penetrate into the surface of the pavement at negative 7.25 inches. And for each result, you can also save that as a CSV file, which we can save to the desktop. So once we can open the CSV file, so this file will give you the full record of where on the surface of the road pavement and where the corresponding at the car bottom will have the contact, and also give you how much the distance between the lowest point of the vehicle bottom to the actual surface of the pavement. So this is our 3D version, but in the case if 3D data is not available, you can still using the software use the 2D version, so which you only need to have the profile line of the highway. So you can use the profile and also the same vehicle dimensions data to calculate the hump crossing to perform the hump crossing analysis. So let's do another 2D demo here. Very similar as the 3D demo here that I showed earlier. So you first open the crossing file, but this one became different because instead of X, Y, Z 3D for the 2D analysis, you only need the X and Z, the two sets of data. Okay, as you can see, this is the 2D profile line of this surface. And similarly, you also have the input data for the different vehicles at your choice. Okay. Calculate. Yeah, this is the same as the 3D. So the program will run for all the vehicle listed in the Excel sheets, which you can also add or modify any vehicle you used for your own interest. Okay. So as I plotted here, this is still for the rear loaded garbage truck, and the picture on the top, the blue line is the crossing profile, and the red line is the lowest point of the vehicle, the path when the vehicle moving over the surface. The bottom is the distance of the lowest point of the vehicle bottom to the surface. So they show. So here we can see when the garbage truck drive over the surface, actually all the point at the bottom of the vehicle are above the surface. So the corresponding distance shown in the bottom here, so everything is like above 8 inches, so there's no contact point, so this is no hump crossing for the garbage truck. We can take a look at school bus. So the school bus also show the same, but you can see at some point it's only about 2 inches between the surface and the lowest point of the vehicle bottom. If you change to a lowboy trailers, so for this one, from the top figure we can see there's actually a contact point where the lowest point of the vehicle will be actually lower than the actual physical surface, which means the vehicle will get stuck or scratched at this point. And also the corresponding of the distance between the bottom of the trailer will have the virtual distance differences here as shown to about -3 inches, which is at much severer conditions. So from here we can tell at where the vehicle will start to hang up on the surface. And also from this we can have the potential ability to calculate the mitigation solutions. So how we change the crossing pavement surface to mitigate this hump crossing problem for each kind of vehicle. So similarly, you can also save any vehicle result as a CSV file. The contact point at the XYZ location, but here you can only see the actual contact point at along the x-axis, and also how much depth it have into the bottom. Okay, so this is the end of this software demo, and please contact me, and if you want to use it, because this is a part of my dissertation, Ph.D. dissertation research result. So since I graduated and we made the first software, and we want to provide it to the different state DOT, so the railroad as a free software, so you can use it to make the hump crossing a much safer location for all the road users. Thank you. Bye-bye.